please welcome the third team that's going to present the project called Service to Power. Please welcome Team 20.
Good afternoon, Honorable Judge. We are Team 20. My name is Heidi.
My name is Amy.
My name is Both. It's a great honor to be here today to present our project, Step to Power. Taiwan is a small island that its air pollution problem is among the most severe of developing countries. Since childhood, we hear a lot about air pollution issues and the disease it causes. However, how exactly does air pollution occur? And also, how can we reduce it? Simply put, the most efficient way is to reduce reliance on fossil fuel. Through our observation and statistical analysis, we discovered a sobering reality. Over 80% of our power in our communities come from thermal power plants. This heavy reliance is the primary driver behind Taiwan's severe air pollution. The cause of the pollution measured in human health. Many citizens in Taiwan continue to suffer from cardiopulmonary issues and allergies, which are directly linked to poor air quality.
Moreover, Taiwan is expected to face a power shortage in the near future because of the development of AI industry. And the current green energy sources are unstable and inefficient. And for example, although solar energy accounts for the largest proportion, nearly half of all green energy generation, it cannot generate electricity at night. And bioenergy is another energy that is very stable and a new energy. But because it's a neutral technology, its power output is very low. Wind and power are heavily influenced with seasons. Both dry seasons and wind and power during this period can result in no electricity. We have also considered nuclear power, which is highly efficient and has high generation capacity. However, it is not widely adopted in Taiwan because of policy and safety concerns.
Therefore, to support SDG Goals 7 and 11, clean energy and sustainable cities, we began to ask, is that a way to generate electricity that does not largely affect the weather, can adapt to any environment, and can generate electricity when people are moving around? We began to explore the potential of connected energy harvest and health, collecting mechanical energy from every footstep.
Our initial idea was to use an electromagnetic induction. That's the kind of when we shake it, the magnet inside will move up and down, activating the process to generate electricity. In this utilized in theory, what people step on the tile, but it's placed like a curtain, and the spring will pass it back and generate the electricity.
By successfully generating electricity through the flow of people, green energy generation will no longer be limited by nature, but will be sustainable adaptation, high urban speed, and can generate electricity uninterruptedly. To be realistic, we evaluate the feasibility of the project through three distinct lenses: population, climate, and financial viability. Because our project depends on the frequency of staff, we first analyze the population to calculate how much energy we can generate. By analyzing the official tourism statistics from the tourism administration, we identified 5 high-traffic districts in Taichung, including the Taichung train station, Dingguan department store, Parkland by CMP, Yizhang Street, and Dongjia night market. Of these 5 locations, due to the high degree of repetition in some characteristics, we eventually narrowed down the analysis to the following 3 locations. The first one we chose is Taichung train station, as it has the largest and most stable population flow. Then we chose Xinguan over Parkland, as both have high weekend crowds. Xinguan, which is near to the city hall station, ensures consistent daily traffic, making it a more reliable energy source than the site that only peak on weekends. We also observed Yizhong Street and Dongjia night markets, which both posted a unique aggregate, nighttime food flow. Though the value in Delhi is lower, the ability to generate electricity in the evening is better. Finally, since Yizhong Street had a consistent flow of students, it becomes the most suitable place to put the child.
Next, we will analyze the pedestrian flow and improvement methods. Before proceeding with analysis, we must clarify that although it is now 2026, the information for 2025 and 2026 is not complete as it was in 2024. Therefore, to ensure no data omissions, we chose to use the closing year with complete data, 2024. So, let's start with our first one, Taichung train station. Based on the 2024 Annual Statistics website, we found out that Taichung train station accounts for 47% of all passengers in all train stations in Taichung. And our placing style of the tile is based on population. First, the ticket gate. This cooling tower here can not only connect a large number of tickets, but also avoid large-scale installation. Second, bus transit corridors. The long walking distance between trains and buses allows us to collect more footsteps per person. Third, the escalator engine. At a train station, people often carry heavy luggage, which make it necessary to take the escalator.
The second zone is Yizhong Street. Yizhong Street crowd is highly stable. Unlike tourists who stay away when they rest, students provide a consistent flow because they need to attend classes nearby. Next, we need to consider where to install kinetic energy harvesting tiles. While high distribution density offers much kinetic energy, the wet distribution makes maintenance difficult, and heavy vehicles may damage the tiles. Consequently, as post-rate installation is impractical, we manually selected Shui building and Sunning was stopped. Shui building and Sunning was stopped with floor and higher maintenance with no vehicle traffic damage, making them ideal for installation. The third one is Xinguang. At the station with the second highest exit volume, City Hall Station provides a consistent flow towards Xinguang, ensure a stable pedestrian flow even on weekdays. We created a chart using data from Taichung City Government's Economic Development Group. The chart shows that Xinguang ranks in revenue among department stores in Taichung, which indirectly indicates it has a large pedestrian flow. We will install our kinetic energy harvesting tiles in both indoor and outdoor plaza. There are 2 advantages of indoor plaza: stable pedestrian flow and protected environment. Protecting our rent and vehicle destruction help reduce the cost. We will install the tiles in the entrance where data shows stable pedestrian flow about 10 hours diameter. For the outdoor plaza, because I'm a proud of my components. In addition to people who come for shopping, also trade performances attract crops, which increases the overall visual flow and thereby generate electrical energy.
Next, I would like to introduce the environmental and climate impact. First is temperature fluctuation. Due to outdoor locations like Edo District and Shingon Outdoor Plaza, temperature changes become especially important. Through data, we can figure out that Taichung's average temperature is much higher than the global average. Second, worldwide surface temperature. In Taichung, known temperatures often hit 40 to 50 degrees Celsius, even 60 in summer. This intense heat often causes overheating and might destroy the device. To address this, we have considered to use a heat-resistant device to ensure stability.
Next, humidity. Taichung's rainfall is highly seasonal, delivering an extra volume in a very short window. Therefore, we utilize waterproof materials to ensure the durability of the system. Our next consideration factor is earthquakes. Taiwan earthquakes occur frequently. Therefore, a track-proofing material is essential, such as free buffer to reduce the impact. In conclusion, environmental challenges such as humidity, high temperatures, or even UV radiations affect our devices, leading to maintenance frequency and material fatigue. By identifying some solutions, we are sure to help minimize these damages. In spite of these waterproof design, we also conceive of other practice. Same as the iPhone battery health, with a charge efficiency rather than 80%, it alerts us to fix it before it breaks. This predictive maintenance keeps our code flow and stable power. We realize that having an idea is easy, but powering the city is hard. So, with the help of AI, we created a simple formula to calculate how much energy we can generate. To calculate our power, we use 4 key values. Start with force and displacement, which physical energy comes from. Then, we multiply it by physical frequency and our system conversion efficiency. Based on the formula and data, we derive our consumption. A 60 kilogram NL with 5 millimeter displacement can generate 7 watts. However, 60 kilogram is just an estimation. To be more precise, we use weight average based on the age distribution of our 3 locations. After analyzing the energy, the average weight are 60, 50, and 55 kilograms. By mixing data like physical frequency, ground density, and its impact on heat, we eventually calibrated value to 5.5 watts per person.
However, we must be realistic because the costs are always important. If we look at its long-term value, if we look at its long-term perspective, it is extremely high costs, but it will eventually be cost-effective. Therefore, we come up with some solutions. First, focus on the long-term cost. Through the technology, we can not only earn carbon credits, but also need zero extra effort to help the Earth. Second, everyone can be an actual participant in global issues. Third, sensors to collect data. By tracking the foot traffic, we can collect valuable data for the business and urbans. By combining data and creative engineering, we show that even the simplest human action, walking, can be a solution to global crisis. Every step counts, and every step powers from our future. That's all for our presentation. Thank you for listening.
Very good job for time management. Is there any questions from our judge?
Yes, really, thank you so much. Thank you. So, I really, first of all, I really appreciate the idea that you bring up. I think this is a really great idea, like nowadays, like pollutions and limited resources, energies, and all the petrol now, all of the price is so crazy. And we have like such a good idea of using our day-to-day walking practice to be green energies or new source of energies. That would be very lovely to hear. And I really like the idea of like having this creativities. And I can also see that you have good demonstrations of the data use, how those what you make decisions on how you implement different sensor things to different area, how to work on it. And then you also like with this little tools to show that how it works and draw our attention. So I really love it. And for my questions to you guys is like when you try to collect your data, when you try to like do your research, like how do you start with this idea? I really want to come up to see what makes you come up with an idea that should focus on energy. How you treat this customer is.
The first time we listened to the tutorial project is when we, in a class, our teacher told us that in UK, one company called Clean Tech Company have come up with this project. And so we think this maybe it is possible in the future. So we, after searching and analyzing the data like this competition, we want to, maybe in future, we can conduct this project.
Yeah, really great. I really appreciate that. That's like for Shuttle, like maybe doing some promotion about Shuttle. So for Shuttle, we are really want to teach students with global view. Like the area that now you are focusing on is not only limited to Taiwan. Definitely, this is a more global issue, and you bring up global issue and to look at it as a student angle, and then later on when you get more knowledge on science, on how to implement it, and the great things you also analyze is how helpful it can be, like all the cost management, that area I really appreciate. Thank you.
Other questions?
One thing, I think, first of all, I was really impressed because you guys have a very clear decision-making process. It's like very, very well done how we arrive at which places we're going to implement the project and why. So for me, the clarity is really there. I really appreciate that. One question is, do we have, I know this technology exists, right? And we've seen it maybe in a lab, right? We've had a great live demonstration. Do we have any like real world applications that we've seen where this has been implemented, and do you know the success of those?
According to this question, we have mentioned this, like she said, the UK company, that Clean Tech company, has just adapted that in many places and global, maybe 20 situations, 20 locations to put those. It's a really exists technology.
Okay, thank you very much. Please give Team 20 applause again. It's always nice